Good morning, everyone. Thank you for joining us for our final Capstone presentation. As you can see, we are the founders of HeatConnect because we have a slightly different approach. And I want to start by introducing my incredible team. We have Ferdinand, our technical lead, Nitika, R&D lead, Rifqi, our UI UX designer, and I'm Manisha, the project lead. And I want to take a moment to thank Christina and Akarsha. Without their industry expertise and guidance, we wouldn't be here right now. So because of our friends, you guys already know the 6 sprints that we're following for all of the projects. So I want to dive straight into the first sprint, which is understanding the problem space. And I want to start with 2 questions for the audience. How much industrial heat energy do you guys think is wasted in the US each year? Yes.
I guess 25% to 20% or something.
Okay, now I have a follow-up question. How much of it do you think is currently reused?
Out of that, maybe 10% or something. Like maybe.
Okay, let's keep that in mind. Here are the actual stats. As you guys can see, 60% of industrial energy in the United States is wasted as heat annually. And although up to 30% of it is reusable, there is no solution to do something like that. And this impact leads to energy wastage, higher cost, and increased carbon emission. That's where HeatConnect comes in. Our solution aims to bridge this gap with our B2B heat energy matchmaking platform that's going to connect waste heat energy producers to consumers, improving their sustainability metrics for both sides of our team. So moving on to our key user personas. On one side, we have the Columbia University pool, and on the other side, we have a data center in New York City. So for Columbia University pool, their main points are like the high heating costs, and they also want to improve their sustainability metrics, whereas for the data center, they have a lot of heat energy without no secondary use, and they also want to reduce their carbon footprint. And they serve as the supply and demand for HeatConnect for our platform. Moving on to our product molecule, by now you guys already know our person who our users are heat producers and consumers, and their problem is that since there is no way to connect these two together, there's a lot of heat energy being wasted and they're spending a lot of money. And that's where our product molecule, our solution, comes in. Our matchmaking platform aims to transform waste heat energy into something resourceful within a close radius for both our producers and consumers. Moving on to a high-level view of our matchmaking platform, we've divided into 3 steps essentially. First, we have data collection. We're gonna go to the producers and consumers and collect data like their location, their heat capacity, demand, and their schedules. Then we also have a proximity matching. We want to make sure that when we create these matches, they are within a 3-mile radius so that they're close enough so that we don't lose heat energy while transportation, also keeping the transportation cost low. And the main criteria that we have is temperature, quality, and the schedules for both our producers and consumers. We've also done the empathy map just to really narrow down the pain points and the goals for our users and to make sure that HeatConnect addresses those pain points while we deliver value to them. Now moving on to our second sprint.
So for our sprint 2, we really wanted to explore our problem space. We focused on 3 areas, which is the first one is to understand the scale of the heat that is being wasted, and also to study the market potential. And the third one would be identifying the gaps that exist, identifying the gaps in the existing solutions. So this research sort of laid the foundation for validating the concept of HeatConnect. Industrial processes, they waste up to 13 quadrillion BTU of heat annually, and on the demand side, residential buildings, they account for around 12.5 quadrillion BTU annually. So this whole these numbers are clearly mismatched. On one side, heat is being wasted, and on another side, heat is critically needed. And for our initial geographic target, we chose New York City because buildings in New York City, around 67% of them are responsible for the city's carbon emissions. And with over 12,000 high-rises and a huge demand for heat, we felt like this was a perfect use case for HeatConnect. The waste heat recovery market is underdeveloped with its with the key companies like Siemens and Power Market. They focus on more hardware infrastructure and energy trading. HeatConnect, we wanted HeatConnect to gap the we wanted HeatConnect to act as a platform to connect producers and consumers. So this is, the Stockholm Data Parks initiative was started by Sweden, and the aim of this initiative was to make sure that 10% of all the heating requirements in Stockholm were supplied from data centers in order to align with Sweden's goal of being fossil fuel free by 2040. So if a city like Stockholm is able to integrate sustainable practices into its urban heating systems, there's no reason why New York shouldn't be able to do such things. And moving on, for example, in New York Bathhouse, which is a spa, it is reusing waste heat that is coming off of Bitcoin mining operations in order to heat its pools. So if Bitcoin mining operations are able to give power such things, I feel like data centers have much more potential to supply heat to residential buildings.
So moving on to the use case. In our research, we made two analyses on the use cases. The first use case, we're trying to analyze our campus facility data center to heat the pool in our gym. So the requirements for the pool to be heat is first is stable temperature, and also the water heating system. So we are hypothetically assume that we have a medium-sized data center around the nearby the pool, which can be connected, and from our calculation, we can reduce cost until 70%, or around $1,244. This is not only for the cost-saving priority, but also for the sustainability improvement of our campus. Second use case, in New York City itself, we have like 12,000 high-rise buildings and medium-sized buildings. But we just imagine how a medium-sized data center could heat up a building, a 100-unit apartment buildings, for example. But what the requirements of the temperature for the heating of the building? Firstly, is optimized temperature and well-distributed heat, and also the energy storage system. And from our analysis, like this is just a hypothetical analysis, for a unit, we can save $500 to $1,000, for example, after the connection between producer and the consumers. And annually, they can save like $84,000, and it can reduce the heating cost by 60 to 70%. So to better understand our user and consumers sides, we use affinity diagram to refine our digital platform and our product. So the key focus area includes we try to understand the stakeholder needs, and then we try to understand their critical pain points, how they will utilize this waste heat, and also the opportunities of the sustainability realm, and what happens after they are connected. So we are trying to analyze how the consumers will connect or will transport the waste heat. There are three methods basically in the industry that has been used. The most popular one is piping systems. The radius is only 3 miles. This is because to maintain the energy quality being transported. Piping systems can be engineered with conventional system. There are a lot of companies that provides consultancy on building the system. The second thing is mobile heat transport. This is not, we can say this is not common because it's not being used commonly right now, but there are technologies like waste heat battery in the UK or in the Europe. And also the third one, this is more or less common, it's called thermal storage for transport. So the thermal storage, they have a molten salt materials inside to keep the thermal, to maintain the temperature of the heat and then being transported. So some potential partners that we have developed, like NG, Veolia, Shark Energy Systems, they provide a real waste heat transportation that can be used between the producer and consumers. And for the stakeholder analysis, we have core stakeholders, producers, for example, like data centers, industrial facilities, power plants, or other facilities that produce heat, waste heat that can that can be recycled or be reused by other facility that need heats. This called the consumers. It can be like pools, greenhouses, commercial buildings, etc. And the key part is we want to manage closely the data centers as the producers, and we want to keep informed the engineering firms and also the environmental NGOs.
All right, moving on to Sprint 3. Our goal in Sprint 3 was creating a low-fi wireframe. Our wireframe is modern and simple, but it's easy to navigate. We also create some important wireframe for our features, and this is the matchmaking algorithm that my friends already told before. So there are 3 steps in the matchmaking platform. First is data collection. We collect important data from producer and consumer. We collect a location, heat output, or heat demand, and also the temperature needs and schedule of the usage. Second one, we do the compatibility matching. We match within 3 miles proximity, and we do the heat alignment between consumer and the producer. And the last one is scoring and ranking. We weight scoring based on the proximity, temperature match, quantity match, and schedule alignment. In Sprint 4, we are doing the test with some stakeholders. We do the interview with Mirdula. She was from Master Science of Sustainability Management program, and Emmanuel Deosilalahi. He is an energy professional, and we got some key insights. First is there are a big financial opportunity for waste heat producer, and they give us some business model suggestion, such as a subscription model or transaction-based model. And they also inform us that there are some barriers to adoption, and there are also some policy and regulatory context that can support our initiative. They also give us some recommendation, and they also give some insight of our strength. And moving on to Sprint 5, we are creating a prototype here. This is our prototype. We still create a modern and clean prototype. Let me show the demo. All right, so this is the landing page. In this page, we show our selling point. We can transfer waste heat into a value, and this is how our platform works in a simple way. And also we also recently added heat producer and consumer to show that our platform is active and growing. And this is the about page. In this page, we show our story and our goals, and how we create a value by doing a smart matchmaking. And this is our impact on the sustainability. Moving on to the login page. So this is the login page. We keep it simple and easy to understand and to navigate. This is the example of a dashboard for a consumer. We can see here that there are some data that Columbia University pool needs. This is the requirement from the pool, and the temperature requirements, and the operating hours. And we also show the performance analytics. This data show sustainability impact and also the business impact. And there's a list of current heat source for the consumer. And our matchmaking process is simple and straightforward. The consumer or the producer can only just enter their location and select their heat capacity need and the operating hours that they need. This is for example. And this is the result. There are 3 match in proximity of 3 miles from the location. And for example, there are there is a data center in 107th Street with 98% match, and we can just contact the producer. And this is the contact form. The consumer can enter the details and the message and send request for connect. And after they send the message, it will bring them back to the dashboard. And after we create a prototype, we do the testing with some of our users and stakeholders, and we got some insight. We already have a user-friendly navigation. We also have a modern design and clear user journey. But we also have got some recommendation from the users. We need to enhance the registration process, upgrade our dashboard so it can include a customizable graph, and we need to add some interactive tools, and we should ensure accessibility, and we have to plan for scalability.
So we did a business model canvas to understand how HeatConnect operates. Our value proposition is it's a turn waste heat into opportunities. So our value proposition is to make sure the heat producers are able to turn their waste heat into revenue and the consumers to reduce cost. And our key partners are heat producers and consumers, as well as regulatory bodies in order to maintain compliance. And our key resources during this entire process are sales, legal, compliance, customer support, and technical resources. Our key activities are matchmaking the producers and the consumers, maintenance of our platform, and making sure we have good relationships with our stakeholders, and marketing. And we generate revenue through subscription fees that we charge for the regular use of our platform, as well as a transaction fees per successful match. And our cost structure involves operational costs for maintaining our platform, employee salaries, marketing costs, and also managing our stakeholders. So HeatConnect is not just a matchmaking platform. It almost acts as a bridge between wasted heat resources and a sustainable solution. So as we leverage the waste heat energy resource, we can reduce costs, lower our emissions, and make sure our planet has a sustainable future. Thank you.
Awesome presentation, guys. Really loved hearing at least a little bit of that, although I wasn't actually present for the whole talk. Just wanted to ask a question out of curiosity. Why did you choose New York, a city, as your launch point?
Well, fun fact, because we're all based out of New York. No, but on a serious note, it's because New York. Wait, let me just get this right. So New York has a lot of laws, like the local law 97, forcing the city to be more energy efficient, and we also have a lot of opportunities for scalability in the future, just because we have a lot of high-rise buildings and there's a lot of waste heat generated in New York itself, which is why we chose New York as our initial target.
That makes sense. Sorry, I didn't see the slide.
No question. Okay, thank you so much for the presentation. I have a question about adoption, right? So what are the challenges of driving the adoption between the producers of this heat and consumers, like the data centers and the residential units? Are there challenges that you think will encounter when trying to strike a partnership with them?
I think the challenge for us is how to convince our new customers, because we don't have existing real connection for now. But I think the first challenge will how to prove to the customer, the first step, how to convince them that our digital platform, basically because our platform is a marketplace action. So imagine like Tinder or Bumble, they sell relationship between human, but we want to connect business to business that needs heating, waste heat especially. So how the challenge will be, how could we convince these businesses to choose our platform for the first step, because we have another plan for our development. So yeah, maybe yes. Does that answer it?
Yeah, thanks.
Can you tell me a little bit about the competitive landscape for waste heat recovery platforms?
So it is very competitive, but the companies that currently exist, they focus more on actual transportation of heat or providing infrastructure for the transportation of heat. So there are a lot of companies like that, but HeatConnect is the first company that does the actual matchmaking, and then we partner with these transportation companies.
Okay.
Quick question. So everybody knows that Elon Musk got a lot of money from his carbon credits that funded his company, and of course, this type of business could actually generate that kind of incentive. I know in the UK they actually have incentives around data centers. Do you think about the possibility of being able to offer that as a side component to motivating your customers to, as your point, get them motivated to pursue this type of technology?
Yeah, that's also our plan. I mean, in the stakeholders level, we want to like introduce our product to, like you said, to Elon Musk's companies, for example. But firstly, I mean, Tesla is a big company for.
Yeah, but he used a lot of the money he got from his carbon credits.
Oh,
He
okay.
used to fund to build the company.
Oh,
He made a lot of money. The government gave him these carbon credits, and he took that and he invested it in his company, which has gotten a lot of pushback because people are like, why did they get these government carbon credits to fund his company? So I'm wondering if, as you walk around Manhattan and you see these little signs on apartment buildings that say B, C, D, because everybody's getting ranked. Is there a possibility of trying to use some of these incentives by creating like a database of you could get this type of credit or that type of credit, or trying to use the financial piece of that as a mechanism?
Yeah, we can definitely use that for our future when we expand the platform.
Yeah.
For right now, our main use case is the Columbia University pool, but when we move to more residential buildings, when we use a data center to power or like
Okay.
provide heating, then we can use these carbon credits for that, and it's definitely a great point that you brought up, so it's definitely great future for us.
Get somebody else to pay for your growth, just like Elon Musk did.
Yeah, you.
Take his model. He did quite well.
We had a question at the back.
Yes.
Oh, okay. So I'm interested in the ranking system algorithm. Since it's a matchmaking, how do you ensure it's like fair in terms of like matchmaking process? Imagine if you have same maybe schedule, same uniform like heat requirement, how do you make it like fair?
Okay. It's like a complex question, but I think it's simple answer. So based on our scoring system, we have a same point for proximity, temperature match, quantity, and schedule and visibility. So if let's say the temperature and quantity match is with they have a similar point, but if the schedule alignment is not one of the match is have a more aligned schedule, it's gonna be have a higher ranking or match. So yeah, depends on the.
So it depends on the criteria.
Yeah.
Got it.
It's a weighted matching system, so we've provided different weights for proximity, temperature, quality, and schedule. So depending on that.
one last question from my side. How do you onboard new producers or new consumers to your platform?
I think with a lot of targeted marketing and also industry events, like for example, there was the Climate Week a couple of months ago, so we can set up booths there, and also maybe through like government initiatives like NY-SERDA, we can partner with them to bring down emissions and market it in that way to bring on customers.
One last question. Great presentation. I like the idea, the concepts. So okay, let's say I get matched up with another company or whatever. Like, what is your involvement from that point on, and like what would you expect to like happen? John, I thought you were kind of going this way, but I was thinking like, okay, you get matched up, and now like, what kind of infrastructure do I need to like maintain this match with the business? Like, do you help with that too?
So you first need to transport. If say you are the consumer and you're matched with the data center, you need the heat. And we've partnered. There's no way to transport otherwise. And we partnered with these transportation companies. So they're gonna help transport to you. And then once a match is made and once you're getting it, we also have a dashboard and you can check more. Like it's a big feature if you want to see more analytics and if you want more support from us, like Elon.
And if I didn't have like that infrastructure already there,
So
Yes.
the first this initial phase, actually we just limit ourselves to be a marketplace platform. But in the future, like you asked, we are thinking of giving both of them a consultancy, but this will generate money because we are thinking of hiring our internal engineers and our partner engineers firms, actually. And the second thing, like Manisha said, maybe we partner with waste heat transports, but this needs also trust from the partners as well because we are new. And the third thing is, we are trying. We will make a contractors product, but we are now focusing on the marketplace for the first stage of this.
Josh, thank you. Great idea.
Any other questions?
I have one last one.
Yeah.
You talked about the infrastructure being one of the barriers to adoption. What's the incentive for some of these partners to continue to develop infrastructure to support the transfer?
So the incentive, do you mean in the waste heat transportation?
Yeah, so who essentially would be responsible for building the infrastructure? Is it the consumer? Is it the producer? Is it these third party?
I understand your question. So we just matchmake the producer and consumers, and after they meet, we will try to facilitate them. We're thinking of have like a account executive to maintain those partnerships, but in terms of how they would make it, how the project will go, how the cost structuring, it we don't think we are not involved in it, but it depends on the consumers and the producer. We just want to miss them, and in the future we want to make money by subscription and stuff. But firstly, we don't take any incentives from the infrastructure. So we just like in the first stage we just like focusing on getting as much as consumers, users as possible.
So any other questions? Did you guys learn anything from this presentation? You did a good job, didn't they?
Yeah.
No other questions? All right, well, wonderful. Thank you so much.